All right, lesson 3.6 is about inverses and one-to-one functions. And in this first part, we are going to focus on inverses. If you recall from Algebra 3 for sure, maybe even Algebra 2, to find the inverse of a point, you are going to switch the x and the y. So for example here, I have the point 8, 4, and it is labeled here as A. In order to find A inverse, which if you just remember here, this little -1 power there means inverse, all I do is I switch the 8 and the 4, and A inverse would be 4, 8. Over here, B inverse, well, if B is -2, 7, B inverse is 7, -2. I just switch them around. If you recall, what you're doing when you find the inverse of a point is you are finding a reflection over the line y equals x. You might want to add that into your notes. You're finding a reflection. So if I look at this graph here, I've got dotted black line here is the line y equals x. A is over here, 8, 4. Here's A prime. This is a reflection over that line. B inverse is down here. B is up there. This is a reflection over that line. So it's just a reflection over the line, y equals x. We're going to find inverses today, whether we're given a graph or an equation. So to find the inverse of the graph, we're going to sketch the inverse. We're just going to switch the x and the y. So I'm just going to take each of these points here, and I'm going to switch the x and the y. So -10, 6 would become the point 6, -10. -6, 0 would become 0, -6. -2, 3 would become 3. I can write here 3, -2. Oops. And 9, 3 would become 3, 9. And then to sketch that inverse, I'm just going to graph each of those points. So 6, 2, 4, 6, 8, 10. 6, -10 would be down here. 0, -6 would be right here. And since there was this arrow going out there, I'm going to start drawing that as I go. 3, -2 is going to be right here, and I'll connect that one. And then 3, 9 is going to be up here, and I will connect that one. I'm a little bit off on my drawing, but that's pretty close to what the inverse would look like. If I want to check and see if it looks right, I can always just kind of sketch in that line, y equals x, and look to see, does that look like it's a reflection over that line? And yes, it does look like that. So that's how you sketch an inverse. Now, what if you're given, instead of a graph, what if you're given an equation? So to find the rule for the inverse of each function. Well, just like with a point, all you do is you switch the x and the y. So if you want to write, the way you do this is to switch x and y and then solve for y. That's what you do for each of these problems. Switch the x and the y and solve for y. Well, if I look at this, f of x, that's my y, right? F of x is y. I'm going to switch them. So this is going to become x equals 3y plus 2, and I'm going to solve for y. So I'm going to subtract 2 from each side. I have x minus 2 equals 3y. I'm going to divide both sides by 3. Looks weird, I know. That crosses out. I get y equals. Now, I would like to write this, actually, instead of y equals, I'm going to write it as f inverse equals. So I'm going to write it as f inverse of x equals, right? That just means it's the inverse. And then I'm going to take this and I'm going to write it in like slope-intercept form. So I'm going to divide the x by 3. So x divided by 3 is like 1/3 x minus 2 divided by 3 would be 2/3. This right here would be my inverse. Switch the x and the y and solve for y, and then write it as an inverse. If you feel like you can do it, why don't you go ahead and try pausing right here and try the second one on your own. And I will do it right here. So this is my y. So I'm going to switch the x and the y. So y equals, oops, I didn't switch them. Switch the x and the y. So x equals the square root of 2y minus 7. Okay, then I'm going to solve for y. So to solve this for y, I'm going to square both sides. I get x squared equals 2y minus 7. I am then going to add 7 to each side, so I have x plus 7. Oops, I forgot to keep that squared. X squared plus 7 equals 2y. I divide both sides by 2. And again, I get y equals, or f inverse of x equals, and then I'm going to split this up into two pieces. So x squared over 2 is the same as 1/2 x squared plus 7 over 2. Oops. Pen, crazy pen. 7 over 2 would be 7/2. And that is my answer for the second one. All right. We're going to try letter C and letter D together because they do get a little bit trickier here as we go through those two problems. So let's start with letter C. This time it's g of x. So when I get to the end, I'm going to write g inverse of x instead of f inverse of x. But I'm going to switch the x and the y. And notice over here there are two x's, which means I'm going to have two y's. So I'm going to have x equals 3y over, over y plus 5. Okay. Now, I could think of this on the left as being x over 1. So this is just a proportion, and I could cross multiply. So I'm going to do that. So I'm going to multiply 1 times 3y, which is 3y, and x times y plus 5, so x times y plus 5. I'm going to distribute this x out to both things. So that would be xy plus 5x is equal to 3y. Now remember that I'm trying to solve for y, so I need to get the y's all on the same side. So I am going to subtract xy from each side to get the y's all over to the left. That would cross that out. I'm going to go up here and write my next part. So I have 3y minus xy equals 5x. Now knowing that I want to get the y's alone, I look at these two terms right here, and I think I'm going to factor out the greatest common factor, which is y. So I'm going to factor out the y. So 3y divided by y is 3, minus xy divided by y is x. And now, to get y by itself, I'm going to divide both sides by 3 minus x. Maybe I can write it. There we go. This 3 minus x crosses out here. And I get y equals, or g inverse of x equals 5x over 3 minus x. It's not going to be wrong if you write y equals, but I'm just by writing g inverse of x, I'm showing that I understand that I found the inverse. All right. Last one when we know the equation. So find the rule for the inverse of each function. So this time we have h of x equals x squared plus 6x. So again, I'm going to switch the x and the y. So this would become the x. These would both become y. So I have y squared plus 6y. If I look at that, it's a quadratic. And usually with the quadratic, I try to factor or do something like that, but I always have to get it equal to 0 first. So I'm going to get it equal to 0 by subtracting x from both sides, minus x. Okay, so if I do that, I have 0 equals y squared plus 6y minus x. So x is kind of like, normally that's a number if this was a trinomial, but it's not. So I can't factor it, but I know that one way I can always solve a quadratic is by using the quadratic formula. And so that's what I'm going to do. I'm going to use the quadratic formula. The a is the number in front of the y squared, which is 1. The b is the coefficient of the y, which is 6. And the c is the constant term, which in this case, there's no number there, but the c is going to be negative x. Okay, that seems a little tricky, but we're going to do it. Okay, so quadratic formula. Quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, and in this case actually it wouldn't be x equals, I should change that. It'd be y equals, because y is my variable here. So y equals. Okay, so we've got Opposite of b. b is 6, that's negative 6. Plus or minus the square root of. b squared. 6 squared is 36 minus 4 times a, which is 1. Oops. 4 times a, which is 1, times c, which is negative x, all divided by 2a. 2 times 1 is 2. Underneath the radical there, I have negative 6 plus or minus the square root of. If I simplify that, negative 4 times 1 times negative x would be plus 4x. So this would be 36 plus 4x all over 2. And then I can simplify that a little more because you might notice underneath the radical here, the 36 and the 4x, those are both perfect squares. So I can't take the perfect square of each of those, but I can factor out a 4. I can factor out the greatest common factor of 4. If I do that, 36 divided by 4 is 9, plus 4x divided by 4 is x. And then I can take the square root of 2 because this is like the square root of 4 times the square root of 9 plus x, so I can take the square root of 4 to be 2. So this is negative 6 plus or minus 2 times the square root of 9 plus x. And then instead of writing the whole thing, I'm sorry, you guys, I don't want to redo this whole video because my pen goes crazy. Instead of writing it the whole thing over 2, I'm going to put over 2 over 2. That means the same thing. And then I can simplify. So my inverse, which in this case it was h of x, so I'm going to go h inverse of x equals negative 6 divided by 2 is negative 3, plus or minus, and then these 2's are going to cross out right here, and it's just the square root of 9 plus x. And that's it. That one gets definitely trickier. Okay, the last 2 problems here are simply graphing a function and its inverse on the same graph and then listing the domain and the range. So we can do this fairly quickly here. Graph f of x equals x squared. So if I think of that, I hope you know that that's a parabola, right? And if I think about a table of x and y values, if 0 is x, 0 squared is 0. If x is 1, 1 squared is 1. If x is negative 1, negative 1 squared is also 1. If I have negative 2 and positive 2 here, either way when I square it, I get 4. So I have a parabola. It opens up, and I'm just going to graph those points. So I have 0, 0. I have 1, 1, negative 1, 1, 2, 4, negative 2, 4. And I have this nice parabola here that is x squared. Okay, what is the domain of that? And I'm going to write this in interval notation. Well, if I look at the domain is the x's, right? This is the x-axis. As I go to the left and as I go to the right, this graph is going to go forever to the left and forever. It's going to keep going forever. So the domain of this is negative infinity to infinity. The range, well, now I'm looking at the y's, right? This is the y-axis. Well, it doesn't ever go below 0, right? It starts at 0 and it's everything above. So from 0 and up, including 0, so it goes from 0 up to infinity. It includes 0, so that would be my bracket. And then infinity is always a parenthesis. This is my domain and range. Now, how would I graph the inverse? Well, the inverse, I would just switch all the points, right? So my new x and my y for my inverse, so this is going to be for the inverse, it would be 0, 0, 1, 1, but here I have to switch 1, negative 1. Here I have to switch 4, negative 2, and then 4, 2. And now I'm going to graph those points. So I have 0, 0, 1, 1, 1, negative 1, 4, 2, 4, negative 2, and 4, positive 2, so I got both of them. This graph is going to look like a sideways parabola. That would be the inverse. To find the domain and the range, all I have to do is switch these 2 around. So the domain for this would be 0 to infinity, The range for this would be negative infinity to infinity. And that's how you would graph an original graph and its inverse on the same graph and find the domain and the range. There's one last problem at the very end there. If you want to pause the video and try it, you can. I will work through it here. If I start with f of x, and I make my little table, f of x is equal to the square root of x. Of course, I'm not going to put a negative number under there because that doesn't make sense. So I'll just start here with 0. The square root of 0 is 0. 1, the square root of 1 is 1. I'm going to skip all the way to 4. The square root of 4 is 2. And then I'd probably skip to 9. The square root of 9 is 3, and so on. So 0, 0, 1, 1. I better undo that. 0, 0, and then 1, 1. And then 4, 2. And then I'm not going to be able to graph 9, 3. But if you remember what the square root graph looks like, it looks like that, right? So its domain, let's see, the domain is the x's. The domain starts at 0 and goes to the right forever. It does include 0, so that would be 0 to infinity. And the range, that's the y's. So the range, this is the y's here. So again, it starts at 0 and it's going to keep going up, so that's also 0 to infinity. To graph the inverse, I switch the x's and the y's. So 0, 0 stays the same. 1, 1 stays the same. That's going to turn into 2, 4 instead of 4, 2. And I'm probably not going to have room, but this would turn into 3, 9. So I've got 0, 0. I've got 1, 1, but this time 2, 4. 3 would go way up here to 9, so it's going to look like, oops, that got a little more straight than I meant it to get. It's going to be a curve, and it's going to go down like this, and it's going to go up like that. That would be what my graph looks like. Then the domain and the range, well, they're identical for this one, so even if I switch them, it's going to stay the same for both of them. The domain is 0 to infinity, and the range is 0 to infinity. And that's it. That is inverses.